load applied on that material. According to direction of force, stress can be classified as tension, compression, torsion, shear, and flexure. Let's take a deeper look into these stress types. Tension occurs when two sets of force are directed away from each other in the same straight line. Also occurs when one end is constrained and the other end is subjected to a force away from the constraint. It's caused by a load that tends to stretch or elongate a body. In fixed prosthodontics, a sticky candy can cause the crowns to be removed by means of a tensile force when the patient tries to open the mouth after the candy is mechanically bonded to opposing teeth or gums. Compressive stress occurs when two sets of force are directed towards each other in the same straight line. Also, it occurs when one end is constrained and the other end is subjected to a force towards the constraint. It's caused by a load that tends to compress or shorten a body. And torsion. Torsion is the twisting of an object due to an applied torque. Torque means rotational force. It tends to turn one end a longitudinal axis while the other is held fixed or turned opposite side. Shear stress occurs when two sets of force are directed parallel to each other but not along the same straight line. It tends to resist the sliding of one portion of a body over another. Shear stress can also be produced by a twisting or torsional action on a material. Bending is a force per unit area of a material that is subjected to flexural loading. A flexural force can produce tensile, compressive, and shear stress in a structure. But in most cases, fracture occurs due to the tensile component. On this slide, you can see the different stress between 3-unit fixed prosthesis and 2-unit cantilever bridge when a flexural force applied. When a force is applied on a body, a dimensional change occurs. This change is called strain. So it's change in length occurring per unit original length of body when a stress is applied. Strain can be elastic or plastic. Elastic strain is reversible. It disappears when force removed. Plastic strain is irreversible. It represents permanent deformation of the material. When the force is removed, it cannot recover. This graph that illustrates the strain resulting from a stress application, known as a stress-strain curve. It is the finest way to illustrate the relationship between stress and strain. Now we will go through each of these features in the further depth. Elastic limit is the same as or almost equal to the proportional limits for many metals. Proportional limit is the highest stress at which stress and strain are directly proportional. Elastic limit is the maximum stress that a material can withstand before the permanent deformation. Below the proportional or elastic limit, there is no permanent deformation. When the stress is removed, the structure returns to its original size. When a stress is applied that exceeds the proportional or elastic limit, The sample is permanently strained. When a material has a high proportional limit value, it suggests that it's more likely to tolerate applied stress without permanent deformation. Partial denture connectors should have a high proportional limit. Materials with a high proportional limit, such as cobalt chromium, are commonly utilized in partial dentures because they can tolerate high loads without permanent deformation. The stress at which a material begins to deform plastically is known as yield strength. The material has undergone some permanent deformation as a result of this stress. Point A is yield strength. Point B shows ultimate strength, the highest stress that a material can endure before breaking down. The highest stress that a material can endure before fracture in tension is defined as ultimate tensile strength, and ultimate compressive strength of a material is the greatest stress it can withstand when it compressed. Elastic modulus, often known as the modulus of elasticity or Young's modulus, it is a measurement of material's elasticity. The slope of the elastic zone of this stress-strain graph shows the stiffness or rigidity of a material, which is measured by the elastic modulus. The elastic stress to elastic strain ratio is used to calculate it. The greater elastic modulus means the greater rigidity. A stiff material will have a high modulus of elasticity, while a flexible material will have a low modulus of elasticity. A steeper slope in the elastic range of stress-strain graphic means that a greater stress application is required to deform material than that of a flatter slope. Flexibility is opposite of rigidity or brittleness. It is defined as the flexural strain that occurs when the material is stressed to its elastic limits. For a material, smaller the elastic modulus means greater the flexibility. Resilience is the resistance of a material to permanent deformation. It is the amount of energy which can be absorbed by the material without being deformed. And toughness is the resistance of a material to fracture. It represents the energy required to stress the material to the point of fracture. Fracture strength of a material is defined as the level of stress at which fracture occurs. It's named as tensile strength, compressive strength, or shear strength, depending on the applied stress. Elongation is the deformation that occurs when a tensile force applied. Dental gold alloys has a high value for elongation, and in general, it is a ductile type of alloy. The capacity of a material to be stretched into wire under tension is referred to as ductility, and the capacity of a metal alloy or other substance to be hammered or rolled into thin sheets without fracturing is known as malleability. Bond strength that holds two materials together is referred to as bond strength. For instance, the bonding strength between porcelain and metal. The impact strength describes the ability of a material to absorb shock and impact energy without breaking. Materials maybe behave more brittle against the forces applied as a sudden impact than the force increasing gradually. The resistance of a material to a force applied in the middle of a bar or beam that's supported at both ends is known as transverse strength, and the maximum stress that a material can endure without breaking for a certain number of cycles is fatigue strength. A crucial fault initiates a crack that propagates across several stress cycles until it breaks suddenly. Tear strength is a measure of how well a material can withstand the effects of tearing. Hardness is the resistance to permanent indentation or penetration. It is the resistance of a material to plastic deformation, which is typically produced by an indentation force. Friction is the resistance to motion of one object moving relative to another. Friction is defined as the resistance to motion experienced by one object when it moves in relation to another. Where uh, is caused by friction. Friction between two objects moving in opposite directions can damage them. Surface interactions, specifically the removal and deformation of material on a surface as a result of the opposite surface mechanical action. And rheology is the study of flow or deformation of materials. There are three rheological properties, and let's take a look deeply in these properties. First one is viscosity. Viscosity is the resistance to flow. This viscosity time graphic shows us a material working time and setting. The material in first graph has short working time, and second graph shows us the material has enough working time and quick setting. And the last one shows the material with perfect working time. Viscoelasticity is the property of materials that exhibits both viscous and elastic characteristics at the same time. Creep is the tendency of a solid material to move slowly or deform permanently under the influence of mechanical stress. It can occur as a result of long-term exposure to high levels of stress that are still below the yield strength of the material. So, thank you for your attention. I will put the slides in your classroom today. If you have anything to ask, please ask now or email me. Here is my email. Is there any question? Var mı arkadaşlar sorusu olan? Sanırım yok. Okay. See you next week.